So today I'm going to be going over the average atomic mass and how to calculate that and what that all means. This is a pretty fundamental core formula that you're going to need to know for chemistry, so I just want to go over this real quick. First off, the formula for this, so the average atomic mass is equal or equals, in parentheses, the percent of abundance of isotope 1 times the mass of isotope 1 plus the percent of abundance of isotope 2 times the mass of isotope 2, and then you're going to divide that by 100. An isotope is essentially a version or variant of an element. They all have the same number of protons, just with different neutrons. So carbon 12, for example, has 6 protons plus 6 neutrons. Carbon 13 has 6 protons plus 7 neutrons, right? So that's all a isotope really is. So AMU is kind of the unit or the unit that we're going to use. That just stands for atomic mass unit, right? So when I'm writing AMU out, that's all that means, right? The reason that we use AMU is because atoms are too small to just single them out. So the AMU gives a convenient scale for atomic and subatomic masses. It's important to know that 1 proton equals 1 AMU, and then 1 neutron equals 1 AMU. I wouldn't say it's necessarily too important, but it's kind of convenient to know. So for example, if I had 13 protons and 5 neutrons, my atomic mass unit would be 18, right? Because 13 plus 5 is 18. So I did write out some kind of formulas and some equations that we can go over. So chlorine 35 has a mass of 34.97 AMU and an abundance of 75.77%, right? So that's isotope 1. Isotope 2, chlorine 37, has a mass of 36.97 AMU and a abundance of 24.23%. And so if we look at the formula here, right, so isotope 1, the percent of abundance times the mass of isotope 1 right here. So we can see that I have the abundance, so I have 75.77% times the mass of isotope 1. So I multiply that together, add that to the same rule applies for the second isotope. So it'd be abundance right here, and then I have mass right here. So we'll multiply that together, divide that by 100, and then the total that you get is 35.46, and that is atomic mass unit, right? If we're doing 3 isotopes, same rule still applies. But if we had 3 isotopes, for example, so magnesium 24, mass of 23.99 atomic mass unit, or AMUs, or AMU, we have an abundance which is equal to 78.99%. Sorry, I'm covering that right there. And then we do the same thing for magnesium 25, 24.99 AMU with an abundance of 10%, and then magnesium 26 with a mass of 25.98 AMU and an abundance of 11.01%. Same thing, right? So this is the formula from the top: isotope 1 percentage, isotope 2, or I'm sorry, isotope 1 mass, isotope 2 percentage, isotope 2 mass. If there's a third isotope, we just put times mass of isotope 3, right? So it's all the same, right? And then if we calculate that out, we get 24.31 AMU, right? So this is a little practice problem that I wrote down here that we're going to go through together. Boron 10 has a mass of 10.1 AMU, an abundance of 19.90% of abundance, right? So the first thing we're going to do is we're going to write out 19.90 times 10.01, because that is 10.01 is the mass and the percent of abundance is 19.90. Now for boron 2, the different isotope, isotope 2, that has a percent of abundance of 80.10%, right? And that has a mass of 11.01. All right, so I'm gonna do this math real quick and then I will give you guys the answer in a second. I just did the math and we can see that the answer is 10.081, right? So this formula it's really simple once you get the hang of it. It's the same thing with every formula in chemistry. Once it clicks, it clicks. Like, it's super easy to understand. All you have to know is the formula. So that is how you calculate the average average atomic mass. In the next video, I'm going to be going over dimensional analysis, and then I will probably also go over prefix multiplication, which is super simple and it's kind of goes hand in hand with dimensional analysis. But yeah, I hope that was super easy to understand, and yeah.